So today's class for light and optical systems, we're looking at topic 8, which is beyond light. And we just finished watching this video on electromagnetism. So we're looking at the electromagnetic spectrum today. So light is classified as electromagnetic radiation. So visible light, which we see right here on the spectrum, visible light energy, and all the invisible forms of radiant energy, they all exist on this electromagnetic spectrum. All right, so what we'll notice here is as we move to the right, we see a decrease in wavelength, but an increase in frequency. So notice that the waves are much closer together. All right, so that's an increase in frequency. So on the left-hand side of visible light, we will see the infrared, the microwave, the radio waves. On the right-hand side, we see the UV, the ultraviolet, the X-rays, and the gamma rays. Okay, and then here is the visible light that we were looking at in the video. And notice it goes in that order of Roy G. Biv. So different colors of light, they represent the different frequencies and wavelengths of light. So when we look at the color red, it has a wavelength of about 700 nanometers. It has a frequency of 4.3 times 10 to the 14 hertz. All right, so what you'll notice with, as you go from red to violet, the wavelength is decreasing, but the frequency is increasing. All right, so keep that in mind. And the nanometer is a very, very tiny measurement. It's equal to 0.000000001 meter, so it's tiny, unit. All right, just another diagram here. Showing again the visible light is here. We have the infrared, microwave, radio waves. On the right hand side we have the ultraviolet, X-ray, and the gamma ray. All right, so longer wavelengths here, but lower energy and lower frequency. As we move to the right hand side, it's a shorter wavelength. Notice that the waves are closer together, therefore higher energy and a higher frequency. Okay, so next we're going to start talking about uses of the electromagnetic spectrum. So radio waves, these are very important for communications around the world. So radio waves are used to communicate all around the world. The FM radio waves are longer than AM radio waves. So there's also used in space. So that sort of thing. Microwaves, they're shorter than radio waves. So the frequency is therefore higher. They carry more energy, so we can use it to heat food. They make the water particles move in our food, and that's what causes our food to heat up. All right, it's the movement of those water molecules. Next, we have infrared waves. We can't see them, but they are felt as heat, so from like fire and so on. There is special equipment that can sense the infrared radiation, so that can detect hotter and cooler areas, and then we can make these thermograms, which are images of infrared radiation. All right, so this would be a thermogram. Then we have UV light, ultraviolet light, so much more energy now than visible light. It can burn the skin, it can increase the risk of skin cancer. Most of the sun's UV rays, they do get absorbed by the Earth's ozone layer, but it is still recommended to wear sunblock, sunscreen, and so on when outdoors. It just provides a layer that'll prevent the UV rays from reaching your skin. Next are X-rays. X-rays are extremely high energy radiation. It can penetrate through our tissues. So X-rays, we can get an image of bones as shown here. So medical imaging and so on. And then gamma rays are important because then they can be used to kill cancer cells. So short bursts of these rays are used to kill cancer cells, but they have to be very, very careful because if there's long-term exposure to gamma rays, it can also cause cancer. All right, so you'll notice that technicians who are working with this type of radiation, they'll always protect themselves and parts of the body with lead aprons because X-rays cannot penetrate through lead. All right, so if you've ever gone to the dentist, maybe they've made you wear a lead apron or something, and that'll prevent those X-rays or gamma rays from getting through. All right, so we'll just look at a little bit in more detail. So infrared radiation, this was that heat radiation. We cannot see it, but we can feel it. Right? Anything that's warmer than the surroundings, it emits infrared rays. Motion sensors, burglar alarms, heat lamps, etc. use infrared radiation. So here, infrared lamps called brood lights are used to keep baby chicks warm. Okay, so that's infrared radiation. Here's another picture of a thermogram. This is of a hand. So again, it could be used in medical areas. It can help diagnose, for example, circulation problems, right? By using this thermogram. It can show the warmer areas are shown with like yellow, orange, and red colors, and then the cooler areas are shown as green, blue, and black. All right, so something like this, thermograms, it can also be used in buildings and houses to see where there is heat loss, right, around windows and doors. So it can be used in those kind of areas as well. Radio waves, so these are longer in wavelength. They have a lower frequency than visible light. Microwaves are a type of radio wave. This has a short wavelength but a high frequency. So these are used in microwave ovens. The microwave ovens, they use a specific wavelength or frequency of microwave that is strongly absorbed by water particles. So then those water particles in the food, they'll absorb the microwaves and then they'll start to vibrate quickly and then they become hot. So only foods that contain water can be heated up in the microwaves. Continuing with the radio waves, microwave frequencies, we can also use them in telecommunication satellites. So microwaves are transmitted to telecommunication satellites that orbit the Earth, and then they receive the microwave signals, they'll amplify them, and then they can retransmit them to the new location. Okay, so these signals that are sent by satellites, they can travel vast distances. So one satellite can replace many ground-based relay stations. Okay, so here, transmitting station, the microwave signals are sent, are transmitted through the atmosphere to the satellite. They get amplified to strengthen them, and then those amplified signals get retransmitted back to Earth. There's the receiving station. Okay, so microwaves can also be used in radar. The microwaves are beamed out through the air. The waves that reflect from an object tell the radar operator the location and speed of the object. So this mechanism can also be used to guide aircraft, but also used like police officers would be using them for speed. All right, so continuing the radio waves. So radio waves that have longer wavelengths than the microwaves can be used to broadcast radio and TV programs. And most radio waves are harmless. They're actually streaming through us right now from radio stations, TV stations, cell phones, even the distant stars. They're all passing all that radiation, that radio waves are passing through our bodies every day. But it's not known whether long-term exposure is harmful from those radio waves. Okay, so here we're just seeing how air traffic controllers are using radar to guide airplanes safely during takeoffs and landings. Remote imaging technology, so RadarSat. This is a Canadian satellite that uses radio waves. It can monitor oceans for ice flows, which are flat pieces of ice, sea ice that's free moving. It can monitor oil spills to see if there's any environmental damage occurring. It can monitor land for sites for oil, natural gas, and minerals. Okay, so here RadarSat-1 takes pictures of Earth's surface using radar, not light. This is an image of the Red River flood in Manitoba. This was in 1997. Landsat, this is another Canadian observation satellite. This records how different parts of the light from the sun reflect back to the satellite. This is important for agriculture, farming. It observes the extent of crops or forests. It can monitor damage caused by insects and disease. Scientists can predict potential regions of famine. This system can also observe weather patterns as well as flooding. Okay, so for both these Landsat and RadarSat info, it gets stored digitally and then it gets broadcast to receiving stations, which will then analyze that data. Next is UV radiation, so ultraviolet radiation, so very energetic, very high in energy. This is what causes tanning of the skin, which is the skin's way of trying to protect itself from the UV waves. So again, wearing sunscreen, wearing light-colored clothing can prevent damage to the skin. This UV radiation, it can damage the eyes, it can damage the cornea. That can lead to the fogging of the cornea and then a slow loss of vision. So it's also important to wear sunglasses that will block UV radiation to protect the eyes. Okay, so you may have heard of the ozone layer and how the ozone layer is getting depleted, and therefore more and more UV radiation is reaching the Earth's surface because of the decrease in Earth's ozone layer. So that ozone layer is very important. It's O3. It's a form of oxygen that's located on Earth's atmosphere, and when this UV radiation reaches the atmosphere, the ozone absorbs much of that UV radiation. But human activities like chemicals from CFCs, freon gas, and like air conditioners, they rise to the atmosphere and they start breaking down the ozone layer and breaking it down. So therefore, more UV radiation can now reach the Earth's surface and cause more problems. All right, so again, those chemicals like the CFCs that were found in aerosol spray cans, in refrigerators and air conditioners. Now many of those spray products are being manufactured without ozone destroying chemicals. And freon, which was used in like air conditioners, is banned in many countries. Okay, so how do we use ultraviolet rays? So it is important in many ways, like treating our water and also in hospitals. It's a high energy level. It's useful to hospitals as well as food processing plants because those UV lamps can kill microorganisms and bacteria on equipment. Small doses of UV light can be beneficial to humans. Skin cells, they produce vitamin D, which keeps our teeth and bones healthy. But to create that vitamin D, our cells need small amounts of UV light. So you may have heard of sometimes babies are born with jaundice. That's a liver condition that causes yellowing of the skin. So to treat this, newborns are usually placed under these UV lamps. So it'll just like lower the bilirubin levels in a baby's blood by photooxidation. So add oxygen to the bilirubin, it'll get dissolved easily in water. So that's what's happening here with this baby under that UV lamp. But notice the eyes are protected from that UV light. X-rays are again very energetic. They can penetrate through our tissue. So they can pass easily through our skin tissue and muscle, but then it gets absorbed by the bone, and then we can have these images to locate like broken bones. This is a fracture, I believe, in the forearm. But people that work with X-rays, they have to protect themselves. So they can either leave the room while the equipment is being used, and then they also use those aprons or shielding pads that are made of lead to protect the body. Gamma rays, these are the way on the right side that we saw on the electromagnetic spectrum. So these are the highest energy of all the waves in the electromagnetic spectrum. They result from nuclear reactions. They can kill cells. So they can be used to destroy cancerous tumors. That is the radiation therapy. But again, people that work with gamma rays, they have to wear like special clothing and special equipment just to keep that radioactive material off the skin. All right, so we'll finish off just by watching this video on the electromagnetic spectrum. We'll pause here.